Welcome everyone, and really appreciate your time spent to joining our webinar today. Topic is making data-driven decision using statistical testing. Hopefully you will get some information from here. I'm Nur Sulawati. I'm the technical support specialist at Bizit Systems. Bizit Systems are independent local and representation for Singapore, Malaysia and Batam, Indonesia. Okay, before we get started, I have some housekeeping item. If you have questions during presentation, please type them into the question box in your control panel. You may send any time throughout the presentation, but I will address them during Q&A session at the end of our webinar. Kindly ensure that you have connected to the audio via computer speaker. So please fill out our survey before you exit the tab. This survey will help us to improve the quality of our upcoming webinar. For your information, this webinar will be recorded and therefore it will be set as listen-only mode to avoid interpretation to the audio recording. The recording will be accessible anytime later on our website www.bizit.com or by subscribing to our YouTube channel, Minitab Malaysia and Singapore. Okay, Minitab was developed 1972. So today, Minitab almost already 50 years in the market. So a lot of company and coming from the various industry have been used Minitab statistical software in daily job or for project improvement like Six Sigma or Lean Six Sigma or data analytic project. Okay, Minitab statistical software is software package for analysis, statistical analysis. Variety of the statistical tools available in Minitab. It will be powerful statistical software since everyone can use, whether you are statistician or non-statistician or non-data sciences. Okay, so this one is some of the tools available in Minitab statistical software. So most of our customer use for quality side, something like for SPC or SQC, something that one. But for information, this software is not only for that. We also have something like reliable engineering, and then for information, new updating Minitab 20 has the new tools inside the relative engineering. We call it the COG regression. Maybe it will help you to solve your problem. Okay, so you can discover on this COG regression for the reliability engineering part. Okay, and then of course, once your process is stable during to the SPC or SQC, and then you know your process is capable, maybe the next step will follow by optimization. Okay, if the objective to optimize the process, DOE will come in the best tools to do optimization. So in Minitab, is you able to starting the journey of design of experiment from you create the design itself. Okay, you choose whether you choose full factorial design or rational design or response surface design or measure or Taguchi method. After that, you can analyze that design, and then of course you can do the prediction inside the DOE itself. Okay, so without experimental, but you aim to do the prediction. So maybe you able to using our statistical model like regression, nonlinear regression, something like by the binary logistic regression or something like the new updating starting with the Minitab 19. You can using the classification and regression tree. Okay, so we also have something like time series. So we have a ARIMA model. And then maybe in starting with the Minitab 20, we almost enhance for the new visualization like heat map, scatter bind plot, and so on. Okay, if let's say you interest on this visualization, last month webinar we cover on the visualization. Okay, so this one is something like process validation, but just I want to highlight that all these tools in the process validation are available in the Minitab statistical software, but not just only one something like you have a go for the step and then you can find the process validation. No. This one is a combination available tools inside the Minitab statistical software. Okay, so with this complete tool for analysis, so our customer coming from various of sector include manufacturing itself. As we know, a lot of type of manufacturing, something like electronic, medical device, and so on. So also have we have also customer from the services. Okay, so today our agenda is to try. Okay, with the overview, the hypothesis testing. I think if let's say you go for the others training or others topic or others sharing regarding the statistical analysis, so this part will be the main topic. So today we focus on the hypothesis testing, and then I will go try show how to run it the Minitab for the one sample test. And then after that, if let's say we have time, we go for the one-way ANOVA. And then after that, I will show, we try simplify the hypothesis testing using the assistant menu button. Okay, so hopefully you will get some input from this webinar. So as I always say that I want to you enhance your ability to use Minitab in your daily job or in your process improvement. Okay, so let's try. Okay, so with the adoption of technology like smart factories, not only to produce more product or will be better service, but it will help us provide availability of our data set. Okay. So maybe no more decision based on the experience, judgment, and assumption. We will use data to make the decision. So something like example, you want to decide who is the better supplier A or supplier B. Maybe you want to see on the sales, the comparison, or something like you want to see on the sales in branch A better than the others branch like branch B. Something like Minitab itself, we have a lot in the various country in the world. So maybe you want to assess Malaysia sales and then versus the Singapore sales and so on. Maybe you want to have something like it's a new design, more reliable. You want to you do put any enhancement in your product or something that one. So you want to see, or you want to something like you recruit the new officer, so you maybe will come in basically you hire the new staff, maybe you can get more productive or something that one, so you want to see on that one. And then we improving our performance. Okay, so if let's say all this kind of the decision you want to do, so probably you can use the hypothesis testing. Okay. So hypothesis testing is something like a rule that specify whether you want to accept or reject to claim about a population depending on the evidence provided by a sample of the data set. So I think a lot of us know about the population. So population is something like collection of people itself, collection of item itself, or collection of the event, which we want to draw the conclusion. So inside the population, we have a sample, something like subset of the population. So the hypothesis testing, as maybe the two opposite hypothesis testing about the population itself is we have a the null hypothesis test, and then we call another one is alternative hypothesis. Okay, so the null we denoted as a hash not. Okay, it's the state by testing. So something, for example, no effect between branch A and branch B, no effect between we call process A and process B, supplier A and supplier B, or no differences between them. Okay, so the alternative hypothesis testing is statement you want to able to conclude is true based on the evidence provided sample data. So if let's say you go for others training part or others text or reference book, maybe hypothesis testing include in the statistical inferential. Okay. Okay, so this one is I always use the statistic in my daily job, but I cannot remember. I can remember what this situation is. Can be used the one sample t-test or z-t-test or two sample t-test or one way ANOVA. So maybe this decision tree will easy to see on this one. So based on this objective, I take this decision tree is in the Minitab itself. So I will go to open the Minitab. Okay, so I will go to open the Minitab and you can see on the assistant. So you go for the assistant. So you see on the hypothesis testing. Okay. So if let's say you go for the hypothesis testing, so you're able to see on this one. So our objective for the hypothesis testing, maybe you want to compare one sample with a target, something like you have something standard one, okay? The temperature for this liquid must be 20 degrees only. So this one is only want to compare one sample with your target. So 20 Fahrenheit or something that one, so it's we call it a target itself. So if let's say you have want to compare two sample each other, so maybe you have a temperature A and temperature B, something that one. So you can go for the two sample t-test or PT test or something, standard deviation or something on. And then want to compare then two sample, something like not only two supplier, maybe have a 5 supplier A, B, C, D, and so on. Or you have branch A, branch B, branch C, and so on. So this one is a more than 2 sample. Okay, so for every 1 sample or 2 sample or more than 2 sample, you're able to see not the only mean you assess, maybe you can go for the parameter, something like standard deviation, or you can go for the effective. So, or your something like categorical, so you can go for the chi-square okay, testing. So if let's say you have a 2 sample, so the same thing, you can assess on the mean, and then you can assess on the standard deviation itself. You can assess on the defective or probability or something that event, okay, or something same we saw. If let's say you go for the 2 sample, more than 2, you can go for compare the mean, compare the standard deviation, and then you compare the relationship of succession between your categorical data set. Okay, so this one is something like you have your objective first. You have 1 sample or 2 sample, or you have more than 2 sample. So easy to see on this decision tree. Okay, I think it will help you. Okay, for me, I think it's a good thing if let's say I need to do the hypothesis testing, which one I need to choose it. Okay, so this one is available in the assistant. So I go for the assistant and you're able to see on the hypothesis testing. Okay, so if let's say you're not sure on this one, you can go for the help me choose this one. Okay, so you can go for the data set, continuous, and so on. So I will show after this how to use the assistant in the Minitab side. Okay, so we go for the next one. Okay, we try with the first one. Okay, so we go for the 1 sample t-test. Okay, use 1 sample t-test to estimate the mean of the population and then to compare to a target value or reference value when you do not know the standard deviation of the population itself. So when to using the t-test, you want to determine whether the population mean differ from the hypothesis mean that you specify. Okay, calculate a range of value that is likely to include the population mean. So it's something like this team run the experiment, team A, team B, team C. So you want to see on the, is it have the same result or not same result or something like one. So you can go for the hypothesis testing. So I think a lot of if let's say you involved on the experimental work, experimental data set. So I think hypothesis testing is coming the best tool to see on this comparison and so on. Okay. So we try with the first example today with the cheese manufacturer suspect that one of the milk supplier is adding water to its milk to increase profits. Okay, so adding water to milk rice is freezing temperature, which is anomaly negative 0.545 Celsius. Okay, so this one is the standard one. Okay, so you want to compare the data set with this standard one. So only one sample involved on this case. Okay, because you suspect that the supplier adding the water into the milk. Okay, so you want to assess on this hypothesis testing. Okay, so I will try, go to the Minitab. Okay. So for this, our new with the Minitab, actually we have a navigator, we have the output pin here, we have the worksheet. So in the one project file, you're able to have a lot of the worksheet. Okay, so if let's say, for this case, we have a 30 worksheet. So if let's say you want to more information, right click on this case, you can go for the worksheet information. So Minitab, so in this column 1, and then the number of column is the 10 column only. So if let's say this is button help you, if let's say you have a lot of variables and then you want to see this one is the number or text data set and so on. So Minitab will go to you. So go to right click. So you choose worksheet information. So we try with this one. Okay. So they come out with then this sample. They collect this data set. So we try where our T sample T test, one sample T test, go to stat, okay, go to basic statistic, you choose one sample T. Okay, why I use one sample T, not the one Z sample T? Since I don't have any historical data like for standard deviation or mean, so that's why I proceed with the one sample T. So I choose one sample T here. So in your information, Minitab have two options, whether you key in your data in one column, one variables, one column, but this way is highly recommended. Okay, but if let's say you have a summarized data set, you have a sample data set, you have a sample mean, your standard deviation, so also available for the t-test. Okay, but today I just only one or more sample on each column only. So for this case, I choose one. Okay, and then I go for the perform hypothesis testing test. Okay, for this mean, I have the standard one. Okay, just now, get is 0.545. Okay. Okay, and then I go, maybe go for the option. Okay, so if let's say you're not using this default setting one, so maybe you're using 1%, okay, 90%, okay. For this case, I will try with the more mean, more than hypothesis mean. Okay, click on this one, then click OK, and then I want to see on the graph of visualization. So I choose individual value plot, click OK, and then click OK. So now you get the t-test. Okay. So now you get the t-test. I will do where our one sample t-test, go to stat, go for the basic stat, and then you choose the one sample t-test. So I complete all this dialog box, okay, with the option one, okay, so graph, and then you click OK. So you get the output here. So as we know, for the hypothesis testing, you start with the statement, the hypothesis statement first. So in this output, from this output, you already, Minitab already put this hypothesis testing to you, for you. Okay, so for this case, hash now is a mu equal to this value, and then here is a mu more than this value. So based on the p-value here, is a less than 0.05. So we consider that this one is the significant. So we need to say that this data set is have a differences between this one, okay, for this value. Okay. So we reject this one, okay, and then conclude that the mean freezing temperature is greater than negative 0.545. Okay, so this one is the how you using or you create the hypothesis testing using the Minitab statistical software. Okay, so you look on this statistic, you look on the P value, you compare with the 0.05. Let's say you're using the 0.05, okay, it's less than, we consider that is the significant. Okay, so we reject on this one. Okay, so after you have this kind of the step, maybe you want to see on the visualization. Okay, you put the visualization here. We follow on the individual value plot of the freezer temperature here. So based on this hash now value is outside from this interval. So we consider that this one is, we reject the hash now. Okay, it's if let's say inside this value, so you accept the hash now. So this one is how we use the one sample t-test to decide the decision on this problem. Okay, so I will do back to this one. Okay, already done it. So basically, if let's say you go for others training class or reference book, they start with the statement of the hypothesis testing, but no worries, in Minitab you already have that kind of the statement. Okay, and then they look on the p-value here, it's less than 1. So we reject the hash now. Okay, so we conclude that the mean freezer temperature is greater than negative 0.540. Okay, so this one is the individual value plot. Okay, so of course, after you get this one, you have a reject, and then you conclude that one to verify again, or we call it assumption. Okay, you want to see, you want to assume that the data is sample from the normally distributed population. Okay, so we try on this case, open back to the Minitab, go back to the Minitab back. So how and then where is the normality? So go for the step as a statistic. We have many ways to run the normality test. Okay, for this case here, and then I just choose on the other starting. Okay, so you see on this one is more than. So we consider that the data set is a normally distributed. Or if let's say we try with the traditional one, maybe you go for the histogram first, and then you look on the distribute, okay, the curve itself, or you can go for the basis statistic. Before you go for testing, you go for the graphical summary. So you choose on this one, and then you click OK. So in this one also have the addition Darling testing. Okay, so maybe you go for the basic one. Okay, you go for the mean, standard deviation, and so on. So you check the normality test, is it the normal distribute? So you go back to the hypothesis testing. Or maybe you want to assess this, is it okay or not, okay, acceptable or not? So you can choose the normality plot. Okay, so it will depends on your preference, where is which one is the best to you. Okay, so we go back to the slide. Okay, so the next one is ANOVA. Okay, so this one is quite popular, is ANOVA. Okay, always have a question on this ANOVA. So ANOVA actually is the hypothesis testing that the mean of a 2 or more population are equal. Okay, so ANOVA assess the importance of one or more factor by comparing the response variable means at different factor level. Okay, so before we got further for this ANOVA, you need to make it clear the term we use in the ANOVA. The first is your factor. Factor meaning to say that the explanatory variable in your variables. Okay, the factor is categorical, meaning that the data classified like people, object, or event. That's one. And then the second part is the level, the group of categories that comprise a factor. Okay, and then of course we need to have the response, the variable being measured in the study or continuous or something like, if let's say here is our y, so factor here is a refer to our x. Okay, so it's sometimes we call it, this one is factor, this one is the response, or in term mathematical, this one is we call x, this one is we call y. So for the level, for the x, actually is something like temperature at 20, temperature at 25, or something like duration of time 1 hours, 2 hours, and so on. So the one is considered the level. Okay, so you make it clear on terms we're using for the ANOVA. Okay, so the no hypothesis testing that all the population means factor level are equal, while the alternative hypothesis test that at least one is differences. So maybe you are process chemical engineer, you do the experimental. So you have a catalyst 1, catalyst 2, catalyst 3, catalyst 4. So you want to assess, is it have a differences between catalysts. So catalyst itself, we call it the factor. Okay, so catalyst 1, 2, 3, 4. So we call it, this one is the level. Okay, maybe this one is the strength or something, that one. So that one is, we consider that is a response. Okay. So today we focus on the one-way ANOVA. So we use one-way ANOVA when you have a categorical factor or your X, and then your continuous response, your Y. We want to determine the whether population means of a two or group differ. Okay, first thing we need see on the one way, is it have differences. If let's say have differences, we continue that analysis we call comparison. Okay, comparison between catalyst 1 and 2, maybe catalyst 1 and 3, catalyst 1 and 4. So we can go further for comparison method. So for example, your situation something like you are the mean strength of the plastic sample from the 4 suppliers statistically different. So the statement or question, okay, you need to do the decision for this question. So one way ANOVA is the best tool to answer this question if you have a data collection. Okay, it's like something like you just only have judgment, something that one is not, you cannot use the one way ANOVA. Okay, it's something like maybe you want to have something as problem like something like is computation more efficient with a few additive A, few additive B, or no few additive. So you have a more than 2 or group of the additive. So you want to see on the efficiency on this one. So all this problem maybe can solve it by the one-way ANOVA. But as we know, one-way ANOVA or what ANOVA hypothesis testing itself is the statistical method, okay, a statistical analysis. So you not able to avoid this thing, is verify the error terms, okay? So this one is you need to consider your error, okay, your residual, or sometimes we call residual. So it must be independent, okay? And then the second one must be your residual, not your response. Okay, your residual must be a normal distribution. And then, of course, your residual, your error must be a constant variance across all the factors. And then after you fulfill this assumption, so you can consider your ANOVA is acceptable. Okay, you can rely on your ANOVA decision. Okay, once this assumption are fulfilled. Okay, so we try with this example. Okay, so manufacturing facilities operate a machining process that provide aluminum part for an automotive application. Okay, the part have male gasket sealing surface. The facility has a heavy problem with the part filling leaks test. Okay, a quality engineer has determined the aluminum part have the poor surface finish with a cost leak. They collect a 60 roundness sample with the finish 20 sample for each of 3 fixture. So fixture here is our factor. Okay, feature 1, feature 2, feature 3 is referred to our level. So the roundness sample here is our response. Okay, so before you go further, so you need to make sure which one is your factor, which one is your level, how many level you have, and then after that, what is your response on this case? Okay, I think if let's say you are coming from the quality side or quality background, something Six Sigma or Six Sigma, you are familiar with the input output. Okay, so from the input side, maybe we are the X, output side, maybe we are the Y. So from the input itself, we have a lot of input. So which one is the best one before you go further for your Y input? Okay, so I will try this with this one. I open the Minitab back, okay, but different data set, okay. So on this case, we have the surface roundness value here, and then this one is a feature. We have a 30, 1, 2, and then 3. So every sample for the 1, we take it 20 sample. So for this 2 also, or for 20, and then 3. So total up this one is the 16. So maybe you can go further watch your information, and then you can see on this how many data set in this here. Okay, so not appear anything. So we consider this column is the numeric data set. Okay, so where is our one-way ANOVA? So you can go for the stat. Of course, all the analysis in the stat menu button. Maybe you are able to see on the graph or something like assistant. Okay, but most of them is from the stat menu button. So for this case, stat, basic statistic, ANOVA. Okay, so stat and ANOVA, one-way ANOVA. Just only one here is our surface roundness. Okay, and then this one is a multiple factor here. Okay, multi-level factor. Okay, not the multiple factor. Multiple factor means that you have another factor here. Maybe temperature and so on. Okay, so multi-level factor. So you go for the stat ANOVA, one-way ANOVA. Okay, so for this case is our response, of course, surface roundness, our factor, of course, the feature. Okay, so the same thing, we have the one variable, one column, or you have a separate column for each factor, something like this one is a feature 1, feature 2, feature 3, and so this one you need to use the data in separate column. But for this case, I use on this, okay, one column for other variables, okay. Okay, I need done. Okay, so maybe I try with this one first, click OK. Okay, so the same as just now for the hypothesis testing, you have the hypothesis statement. Okay, before you go further, I will go to stat, go to ANOVA, you choose one-way ANOVA. Why choose one way? Because only one response here. Okay, so for this case, if let's say you open the dialog box, you already know only one factor is only one variables you can insert here. Okay, if let's say something like that one, so you can include more than one variables. This the size of this dialog box. Okay, so for this case, the feature, and then you click OK, so you get this one. So for information, the feature level, so the one is a multi-level, 1 to 30. So based on this, you try with the hypothesis testing, all the mean are equal. Okay, and then the alternative is not all the mean are equal. Okay, so for this case is the significant. They have the differences, okay, between level 1, 2, and 3. So if let's say this case you have a significant, so you need to know which one is the differ. Okay, is it feature 1 and 2, or 1 and 3, or 2 and 3? So you need to check on this one for the analysis. Okay, so you go back to the dialog box. Okay, go back to the dialog box. Maybe you go for the comparison. Okay, since you already have something like significant, have differences between them. So maybe I just choose on the 2K. Okay, and then you click OK, and then maybe I want to check on the assumption. Okay, I just put on the 4-in-1. Click OK, and then click OK. Okay, I will go back to the dialog box. You see on the comparison. So this one is something like you have something differences. We call it procedure, something like 2K or Fisher or not, or HSUC, MBC. But I just only just give this brief idea only. Okay, so when the most or you can go for this, sorry. Okay, sorry, I have this one. This one I take it from the help button. Okay, so if let's say you want to more what is the multiple comparison, they give it you this one, and then this maybe why I need to use 2K, why I need to use the net. Okay, when I need to use the HMC method or something, that one. So the Minitab give you this information. Okay, so you just go for this menu, okay, and then you go for the help, okay, and then they pop up on this data, okay, or information here. So from here is something like I choose 2K. The strength of the 2Ks is a most powerful test when doing all the pairwise comparison. Okay, I want to pair all this one. Okay, so if let's say this unit is a most strength on the test when comparing to a control, something like you do the experimental, you have control group, and then you have group A, group B. So you want to compare that one. So you can maybe the best is method is a unit. Okay, something that one. But for this case, I just want to compare all this one. So that's one I choose the 2Ks, and then I click OK, and then I click OK. Okay, so I get this one. Okay, I go this one. So I get the 2Ks comparison. Okay, I do it this thing since in the p-value have a significant. Okay, that's why I further for this comparison. Okay, so for this case, you find the which one have a similar thing is not significant different. Okay, have a different, so you have a significant different. Okay, so for this case, you can see on this one, here's similarly. Okay, so group 3, 2, and the 3, 1 is similar. Maybe to 1 is not is different between this one. Okay, so this one is Minitab give you something that one means that do not share a letter a significant difference. Okay, so this one is once you know about the differences, so you can go for the comparison. So what type of comparison? You need to go for this one lah. Okay, maybe it will help you. We want which one is the best for your problem. Okay, so for this case. Okay, so I've tried this one. So I try with the hypothesis testing statement. Okay, same for the one sample t-test just now. You need to put your hypothesis testing, and then you assess on the p-value. Okay, and then we recheck, and then could have the different means. So have different means. So which one is the have different means? So you need go for the comparison. Okay, so for this case, I choose the 2Ks method for this case. So in this feature 3 is significant different from the feature 1 and 2 since it does not share any common letter. Okay, feature 3, 1 and feature 3 and 2 are statistically different since the interval do not contain the 0. Okay, so we have this kind of the assessment. You want to look on this group information, or you want to look on this class interval. Okay, so for this case. Okay, so of course, this one is assumption. So once you say that have a differences, and then now you know feature 3 is different between feature 2 and 1. So you need to verify, is it or reliable or not your statement. So you need to go for the residual to support your statement. So for this case, the residual are normally distributed since all the value or residual value in the straight line. Okay, and then the second part you need to know is the constant variation. So we consider the constant because not the something like is a big one, is something like is almost the same, something like one. So we consider that this one is a constant variance. And then the residual are independency, not showing any point. Okay, either any point on any pattern. Okay, something cyclic or seasonal or something like one. So this one is a good one. So for this case, we accept this statement. The feature have a differences. Okay, and once you the assumption, all these assumptions are fulfilled. Okay, so I go back to the Minitab back. Okay, so this one, so you can see on this hypothesis or residual. If let's say you don't want in one for plot, so you go back to this one, go to the graph back. So you want to individual, so you take which one is you want. Okay, you take on this one, and then click OK, and then you click OK. Maybe make it clear on this one, this part. Okay, so make it clear on this part. Maybe you want to see on this part more clearly. Okay. Okay, I'm running. Okay. Okay, so of course, this step, okay, we can use the assistant to run the hypothesis testing. Okay, so assistant is might be appropriate step or step-by-step guidance if let's say you are the new one or you are the expert one. As I mentioned, I also using the assistant to guide me how to do the hypothesis testing. Okay, and then maybe it can assure you success. Okay, and then you can run quickly and easily. Maybe you can interpret your result with confidence since they provide you summary report, variation report, and then report card. And then, of course, you can share your finding with the one click. So you share your finding with one click, not the only from the assistant, but others, something like just now, we show back to this one. Okay, go back. One, so you can right click and then send to Word or send to PowerPoint directly for this one, or you can send from the navigator. So for this case, okay, not the only assistant. Okay, so we try with another example here, but using the assistant. Okay, so a ball bearing manufacturer is concerned that bearing diameter, okay, diameter has shifted away from their target. Okay, so engine consider a change of 0.01 important enough to warrant adjust the equipment. So engineer randomly select and measure 10 bearings only. Okay, so this one is a sample only, is it? So one sample T. So you go back to this one. Okay, the statement they want to prove is the mean of the bearing differ from the 0.5 centimeter. Okay, so we go to the Minitab. So I will choose another data set. Okay, the same data. Sorry, I choose another data set. So they take the sample for 10 sample only, and then they doesn't provide any historical data. So that's why we're using the t-test. So or you can go for the assistant, hypothesis testing. So only one. So maybe you might be trigger. Is it one sample t-test or is it standard deviation? So you can go for the help me choose. For this case, it's the number rate data. Okay, continuous. So what are you compare? Mean versus target or standard deviation versus target. Okay, so for this case, we go for the target only. Okay. Okay, so the column is our bearing. So our target is 0.5. Okay, so for this case, the differ for this case, and then click OK. Okay, I will go to assistant, go to hypothesis testing, and then you choose one sample T. So you complete all this about and then click OK, and then you click OK. So for this case, a lot of our customer love on this kind of the features. Okay, does the mean differ from the 0.5? So the answer is yes. Okay, so this one is a statistical standard deviation, and then this one is the confidence interval. Okay, and then there is a comment here. So if let's say you want to put another comment, okay, you just double click on this case. Okay, so maybe you have any explanation. Okay, more further on this one, so you can put on this one. Okay, and then click. Okay, And then you also have the diagnosis report. Okay, so the pattern, and then of course they have something like detective differences. So this also come in our mind if let's say we go for the hypothesis testing. How many sample we need to take? Okay, so this one is they give it you something that one. But no worries if let's say you have something. How many sample I need to take for this case? So you can go for the stat. Okay, power and sample size you need to using. Okay, so you have the 1T sample test. So sample size, how many you try and error for this case. Okay, you're able to see on this one. And then of course you have the report card. So on this report card, is it help you? So this one is unusual data, outliers, no. Okay, no outliers for this case. Okay, normality, this one is not normality, but this case is because the sample size is less than 20. Okay, and then the sample size is sufficient to detect the differences between the mean and the target itself. Okay, so for this case on this hypothesis testing. Okay, so if let's say you will run the ANOVA using the assistant also can, okay, can go for the assistant hypothesis testing. Okay, but I will using the roughness surface. Okay, so for this case I will using the same thing. Okay, so go for the hypothesis testing. Okay, I will choose the one way ANOVA. If not sure, you can back on this one. Okay, so for this case, more than 2 means. Okay. Okay, so for this case, our Y, okay, your response, your X is your feature. Okay, in this case, if let's say your file level is not 0.05, and then you click OK. Okay, so you get, I will go to assistant, if it's testing, one way ANOVA. So you choose on this one. And then you choose, say they give it you this question. Okay, and then you have this one. Mean comparison chart also available on this one. And then you have comment. There's notice report. Okay, distribution of the data set. Okay, and then they have a power and report for this case. And then of course, they using the report card. But okay, just only one thing you need to know about the Minitab assistant. If let's say for the hypothesis testing, okay, this one is for the ANOVA. They using the equal variance only applicable on this one. They using the Welsh method. Okay. This one is you can able to see on the stat menu. So you can go for the stat menu, ANOVA. So one way ANOVA. Okay, you go for the option 1. Okay, you need to unclick on the assume equal variance. Okay, so you can get the same result on this one. Okay, so this one is differences between stat menu and then assistant menu. Okay, so which method is which does not assume or require that the sample have equal variance. Okay, this one is have a argument between the experts on this one. Okay, but just for your info, if let's say you're using the assistant for the ANOVA, they using the which method. Okay, for this case. Okay, ANOVA, this one. Okay, already done it process. Okay, okay. So one way ANOVA, this one already done on this part. Okay, so if I say you have question, okay, please type them into the question box. Okay, if not enough time, I will reply email to you. Okay, so maybe you not have question on this topic, you have the other topics, you feel free to contact me at the nor.sulawati@bizit.com. Okay, all the other topic, maybe regression or something that one, not that on this topic only. Okay. Multi-response or multi-factor. Okay, one response. Oh, I have a question. Maybe I have one time in the 2 minutes or 3 minutes. Okay, I will try the best one. Okay, Okay, just now show how to, this question is how much is the sample size for hypothesis testing. So just now I show the step how to run, okay, how to get the answer for this question, okay, because we don't know how many, how big your population, okay, so you need to know what is your population first, okay, before you take it the sample, okay. In Minitab will help you on this, okay. Minitab will help you. So I go back to the Minitab, go to stat, go to power and sample size. Okay, if let's say you're looking on the one sample t-test, how many, okay, and then go to two sample t-test or a pair t-test, something like one. So you can access on this. Oh, okay, how many sample or how many power you want, or this part, okay. Okay, really, I will answer this question. Okay. Okay, so this question is what to do if one of the assumption, I think the look on the ANOVA assumption is not met. Okay, so if let's say this happen, maybe you have alternative, you're using the non-parametric test. Okay, non-parametric test. Okay. For ANOVA, of course, for the parametric test, you able to using the classical Wallis or Moore's median test. So where is that one? So go for the stat, go for the non-parametric. Okay, you can see on this Wallis and then Moore median test of Friedman. So if let's say your assumption is not fulfilled, but you need to do the decision on that thing. Okay. Sometimes the actual part is not it's not easy as we showed just now, is it? For the residual is the normal distribute, the variance is constant, the variance is the independently, the actual part is not something that one. So maybe the option part, maybe you can go for the non-metric test. Okay, for the Mann-Whitney or Mann-Whitney is the one sample test. For if ANOVA, you can go for the Wallis for this case. Or maybe another way you can use is you do the transformation. Okay, transform your response first before you go for the ANOVA or something that one. But maybe not all the expertise suggest on that thing. Okay, for the transformation, your response. Okay. Okay, there is a 0.01 requirement indicate the variance that is not required to be included in this analysis. For this case, we just only focus on the, say, bearing just now, is it? Bearing, okay, or on the diameter itself, the mean, the standard one only. The plus, minus, something that is your, maybe your spec, okay, on this one. Maybe your spec. Okay, after doing the one-way ANOVA, is our hypothesis mean is a 50. Do we need to repeat one separate test or this enough to show that we return to the desired result? This question for this. If do we need to repeat? Okay, this one is you are already fulfill the assumption and so on, so you can proceed with the one-way ANOVA. But maybe you want to reliable or something that one. Maybe you want double confirm. You need to go. Maybe you want. Maybe you have a time on that thing, so maybe you can go for the one sample data. But if let's say you're using the one-way ANOVA, you have differences. Your assumption is fulfill assumption, so it's a done. Okay. Okay, I think if let's say you want this presentation slide, you drop your email in the chat box or question Q&A, but I will email to you. Okay. So maybe I just answer this one. Okay, answer done. Okay. So We're back to this one. So if let's say you want more, learn on this part, okay, we highly recommend you join our training, whether in-house or public training. Okay, the training will be based on the mature training by Minitab and will be conducted by Minitab certified trainer. So if let's say you interest on this one, or when or how much the cost or something that one, so you may have to scan barcode on this one. Okay, so you want to see on this one. But if let's say you want know more about this, because for today webinar only access on Min. Okay, maybe your problem you access on the others, something like standard deviation or something that your event, something that one. So I not touch on that one. I just only Min, only one sample test and one way ANOVA. For this case, you have a multiple factor, multiple response. So you need to go for the further one. Maybe you need to join our Minitab training. Okay, for this case. So thank you for your time and attention. Okay, so to learn more about Minitab, we highly recommend you join our training, as just now I show on this one. Okay, so if let's say you want to more interest on this product, please contact us by visit our website www.bizit.com or www.minitab.com, or you want have any question regarding all this product, okay, you may email us to sales@bizit.com or to minitab@bizit.com. Okay, to get more some tips and tricks on our Minitab product, please follow us through the media social like Facebook and link at Minitab Malaysia and Singapore. Okay, to access back our previous webinar for just now, maybe visualization you interest before you go for the hypothesis testing. So you may subscribe our YouTube channel, Minitab Malaysia and Singapore. And then really appreciate if you fill out our survey in order to enhance our webinar session. Okay, so see you next time with different topic and stay safe. Thank you.